Welcome back to ajspeller.com. In today's tutorial, we're going to work on a related rates problem. Here we have a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is sliding away from the wall at a constant rate of 2 feet per second. We need to figure out how fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet away, 15 feet away, and 24 feet away from the wall. So let's begin with a sketch here. So we're going to start by sketching in the wall, and then we're going to sketch in the ground, and then we're going to sketch in the ladder leaning against the wall and touching the ground. Notice here that we've just created a right triangle. Right? With the right triangle, there are several different functions or formulas that we can relate to that. One would be the Pythagorean theorem, and that would be x squared plus y squared is equal to r squared. Another one would be the formula for area, where area is equal to 1/2 the base times the height. Two others would be x is equal to r cosine theta, and another would be y is equal to r sine theta. All right, all these are functions that we could relate back, but if we look at the question, they're not asking anything about area, so we can discard this area formula. They haven't given any information about the angles, so we can discard these two formulas that are trig related. So here we're left with x squared plus y squared is equal to r squared. And now let's go back and let's fill in some information on this right triangle. Well, we know that this here is the ladder, and we're told that the ladder is 25 feet long, so we're going to incorporate this 25 feet right here. Other information that we know is the rate at which the bottom of the ladder, where this here is the base of the ladder, where that base of the ladder is sliding away from the wall. We know that there is at a constant rate of 2 feet per second. So we're going to label the bottom of this ladder, the bottom or the ground of this right triangle x, and as we said, it's moving in that direction. So here we can say that the change in x, or dx, or the change in x over time, so dx dt is the same thing as 2 feet per second. And what we're trying to figure out is how fast is the top of the ladder moving down the wall. So here for the wall, we're going to label that y. We know this is moving, well, we know this is the top of the ladder. We know the ladder is moving in a downward motion, and this here we're trying to figure out, which is dy dt, or the change in y at particular snapshots in time. And we have a snapshot at 7 feet, 15 feet, and 24 feet. So now if we were to rewrite this equation, we end up with x squared plus y squared is equal to r squared. Well, in this problem, r is 25. So here we have 25 squared. So what I want to do now is I want to use implicit differentiation on this equation, and I'm going to take the derivative with respect to time. So here we end up with 2x dx dt, because the derivative of x squared is 2x, plus the derivative of y squared is 2y, and we have to tack on the factor dy dt, and the derivative of the constant 25 squared is 0. And notice we have several variables here: x, dx dt, y, and dy dt. So now at this point, we need to come up with the more information, because we have the x values, which would be the 7, the 15, and the 24. We have dx dt, which is 2. We don't know currently what the y values are, but we can figure out the y values, and once we've done that, we can figure out dy dt. So what we need to do at this point is we need to create a series of snapshots. Alright, so with these snapshots, we're looking particularly at what's going on with the y value when x is 7, what's going on with the y value when x is 15, what's going on with the y value when x is 24. So we're going to come back to this equation here so that we can figure out these values of y. So our first one, we're going to say x is equal to Well, let's do it like this. Let's say when x is 7, when x equals to 7, we need to figure out what y is. So to do that, we're going to use this equation here. So we end up with x squared, whoops, not x. X is actually 7. So we're going to say 7 squared plus y squared is equal to 25 squared. Well, we need to isolate y squared, so we're going to subtract the 7 squared from both sides. So we end up with y squared is equal to 25 squared minus 7 squared. And to figure out y, we need to take the square root of both sides. And in doing that, we figure out that the value for y in this first snapshot is 24. So with that, we're going to make the substitutions necessary into the derivative we found implicitly. So here we're going to write 2 times x. Well, x in this case is going to be 7. dx dt is 2 plus 2 times y. Well, we found y to be 24. And then we tack on the dy dt, and that there's all set equal to 0. At this point, we begin to simplify. 2 times 2 to give me 4, and then 4 times 7 to give me 28, plus 2 times 24 to give me 48, and then I tack on my factor of dy dt. And what I have to do now is I need to subtract 28 from both sides, so I'm left with 48 dy dt is equal to negative 28. Now I'm going to divide everything by 48. So in doing so, these 48s here cancel, and I'm left with dy dt is equal to negative 28 over 48. So at this point, I can divide everything by, let's start by dividing everything by 4. Negative 28 divided by 4 leaves me with a negative 7. And 48 divided by 4 leaves me with 12. And here I left off the units, but this is actually going to be feet per second. So here we see that dy dt, or the change in y, at the moment that the bottom of the ladder is 7 feet from the wall, we see the top of the ladder is falling at negative 7/12 feet per second. All right, we're going to use the same information to continue on. For our next snapshot is when x is equal to 15. So let's just move this up. All right, now we're saying that x is equal to 15, and we're trying to figure out what y is going to turn out to be. Well, we know our equation is going to be 15 squared plus y squared is equal to 25 squared. And again, all I did was take the equation that we started here with, and I did the substitution in for the value of x. All right, now to isolate y squared, we're going to subtract 15 squared from both sides. So we end up with y squared is equal to 25 squared minus 15 squared. Have to take the square root of both sides to just figure out what y is. And with that, we figure out that y turns out to just be 20. So we're going to place 20 here. So now we fall back to our our equation where we figured out, where we did the implicit differentiation. And matter of fact, let me copy that, and I want to just move that down so that we can see that. So let's copy, and I want to paste that in, and we'll move that here so that we can see it. All right, so what we want to do at this point is do our substitutions. We know that we have to use this constant 2. Here we said the x value was 15. dx dt is 2, and again I'm getting that from here where we said dx dt is 2, which comes from the question, plus 2 times y. We just figured y to be 20, and our end goal is to figure out what dy dt is. So what we do now is we begin to simplify. I've got 15 times 2 to give me 30, and then 30 times 2 to give me 60, plus, or 2 times 20 to give me 40. Then I have my dy dt equal to 0. I'm going to subtract 60 from both sides. So I have 40 dy dt is equal to negative 60. And then I'm going to divide everything by 40 so that I can isolate dy dt. So these 40s cancel. So I have dy dt is equal to negative 60 over 40. Well, I can divide by 10. Well, actually, I'm going to divide by 20. So 60 divided by 20 leaves me with a negative 3. And 40 divided by 20 leaves me with 2. So here I have negative 3 over 2 feet per second. And that's how fast the top of the ladder is sliding down when our moment in time where the where the foot of the ladder is 15 feet from the base. All right, and let's do another paste in here so we can see the problem. All right, so here we have the implicit differentiation. We're trying to figure out this time when x is, let me go back up, when x is 24 feet. All right, so here we're saying x is 24. We're trying to figure out what the y value would be. And we know that our equation is going to be x squared, which is going to be 24 squared, plus y squared is equal to 25 squared. Again, where 25 is the length of the ladder. All right, let's isolate y squared. We do that by subtracting 24 squared from both sides. So y squared is equal to 25 squared minus 24 squared. And we take the square root of both sides to just get y. So in doing so, we see that y turns out to just be 7. All right, now we're going to make our substitutions. All right, we have the 2. Here we said x is 24. dx dt we know is 2. That's the rate at which the bottom of the ladder is sliding away from the wall, plus 2 times y. We just figured y to be 7. And ultimately, we want to figure out dy dt, which is the variable for how fast the top of the ladder is sliding down the wall. So again, we go in here to simplify. We have 2 times 2 to give us 4, and then we have 4 times 24. Let's do this here. 24 times 4. Well, that's 16, and that's all right. So that's 8 and 1. So here we have 96 plus 14 dy dt is equal to 0. Again, we're going to subtract 96 from both sides to help get this dy dt by itself. So 14 dy dt is equal to negative 96. And then we're going to divide both sides by 14. We do that to isolate the dy dt. So here we have dy dt is equal to negative 96 over 14. And then once we do that simplification, this turns out to be a negative 48 over 7. And again, that's feet per second. So here what we've done is we figured out these different snapshots in time as the bottom of the ladder is sliding away from the wall. In a future video, we're going to actually show or model each one of these with technology so that we can get a better feel or understanding of what's going on. All right, well, that sums up this tutorial. And as always, thank you for watching another video by ajspeller.com. Have a great day.